In this video, I have a problem here for us to solve. This is an AC circuit and you have to find the current in the branches applying complex number notation. So here's the question. A circuit is arranged as indicated in the figure below. The values being shown. Calculate the value of the current in each branch and each phase relative to the supply voltage. Whenever you are dealing with complex number, you just use your calculator, then you punch it nicely. So I have this branch A, branch B, branch C, and this is my supply voltage, 200 volts, 50 hertz, that is frequency. So I am to find the current in each branch. You know from our direct current, you know that V is equal to IR, right? To find my current in each branch, I need my total voltage, I need my total resistance now, which is impedance. So my total voltage of my impedance will give me my current in each branch. So if I get the voltage across here and I get the impedance across here, I can find the current in this branch. Likewise this and likewise this. So now let me take my first branch. So taking my branch A, I only have a resistor here. So my impedance ZA is simply equal to 20 plus J0 because I don't have any imaginary part. It is purely real. So this is my ZA. Then let's see the branch B. The branch B, I have a resistor 5. Then I have an inductance of what? 0.1. So my ZB will simply have 5 plus. Now I need to find my inductive reactance, not the inductance. So XL is simply equal to 2 pi FL. 2 times pi times my frequency 50 times 0.1 is simply going to give me 31.4. So my impedance ZB will be 5 plus 31.4 G, right? So once I have this is the rectangular form, but you need to convert this one to the polar form as you are going to simplify. So for now, let's leave it in the rectangular form. This is also in the rectangular form. And let me find my VC. My impedance across this branch C, I only have a capacitor here, so I need the capacity reactance, and my capacitance X, my capacity reactance X equals 1 over 2 pi FC, right? So I have 1 over 2 pi 50, then my C is what? 150 micro, so 150, then the 10 to the power 6 will come up, right? So my XC is simply going to give me 21.2. So you know that XC always take negative J operator, so negative J 21.2, and that is my impedances across the various branches. So the next thing to do is to find my current by finding the effective impedances across each branch. So now let's see. So I found my impedances. So now let's see. Having the voltage source here, realize that the voltage source here is across this whole thing. This is the parallel connection of this and this. So the voltage here is across these two. So I need to find the effective resistance of what? A and B. So my ZAB is simply equal to, I have this and have this, right? So ZA is parallel to ZB. Hence I'm going to have my ZA 20 plus 0J, right, times 5 plus 31.4J all over 20 plus 0J plus 5 plus 31.4J. Setting your calculator on the complex mode, you are expected to find ZAB from this expression here to be equal to 13.78 plus J 7.8 ohms. Then you have to convert this one to the polar form, because for division in complex mode we use the polar form. So this in the polar form is simply going to give me 15.84 angle 29.48 degrees. So if you want to convert this to the polar form, you take square root of the square of this and this, that will give me this. Tan inverse of 7.8 over this, that will give me this. Then once I have found my total um, impedance across the A and B, my total impedance in the circuit is simply equal to, you realize that these two are in what, in parallel and in series with this. So I'll just add my total impedance will be equal to ZAB plus what, ZC, right? So to find my ZC, I found it to be purely capacitive, so negative 21.2 J. So I'll have here to be what, 13.78 plus 7.8, then plus negative 21.2 J for this total. And this is simply going to give me in the polar form 19.22 angle negative 44.2 degrees. So when you add this will subtract from the what, this one, the G, but that will give us 13.78. And if you have 7.8 minus 21.2, then you are going to get minus 13.4 G, right? So this one in the polar form is giving me this. So I have my ZT in the polar form. I can find my total current IT, and you know that the total current will be the current that will pass through what, this branch. So my current through the IC, so let's make it IC, this will be IB, then this one will be IE. So my IC is simply equal to my total current, and that is going to give me my total voltage of my total what, impedance. Total voltage is 200 angle 0 in the polar form because it's a voltage pure. Then the impedance here is 19.22 here, angle what, negative 44.2 degrees. So realize that dividing this one will divide this, then this will subtract from our properties. So my IC, which is equal to IT, will be equal to 10.4 angle 44.2 degrees. So meaning the magnitude is 10.4 amperes, and it is the phase difference with respect to the supply voltage is 44.2 degrees. Now we have found a current through the branch C. We need a current through branch A and branch B. To do that, we know that the voltage across, to check, the voltage across only this one is simply found by finding the total impedance times the total current, right? So I multiply the total current by the total impedance, I get the voltage across only this part. So let's see. I know that the total impedance in the polar form from the beginning, I got what, 15.84 and got this, right? So I'm simply going to multiply my impedance. So ZAB multiplied by the total current will give me what, my voltage across AB. So I'll have my total current 10.4 and go what, 44.2, multiplying my 15.84 and go 29.48. So 29.48. So once I have this one is simply going to give me 164.8 angle 73.68 degrees. So this is just a simple multiplication. You can do it on your calculator. Then at this point, and you know the trick here, you simply what? So let's see, you are multiplying, so this will multiply by this, then you add the angles. So you just add the angles. So once I have found my total voltage across my AB, to find the current only across A, so see, now I know the total voltage across these two. To find the current here, I'll just take the impedance here and I'll divide the voltage by this impedance. That's all. So my IA, current in the branch A, is equal to the voltage across AB over the impedance across what? A. Sorry. Right. So this is equal to 164.8 angle 73.68 all over 20. That is giving me 8.24 angle 73.68. Right. This is equal to the angle across A. The current IB is equal to VAB over impedance across B. That will be 164.8 angle 73.68. So 73.68 all over the impedance across B was 31.79 angle 80.95, and that is going to give me what? 5.18 angle negative 7.27 degrees. So the impedance across B, my ZB, that was 5 plus this. You just convert it towards polar form, and that is what I was getting here. 31.79, 80.95. So this becomes the current across B. So at this point, we have found the current across all the branches, and this is the end of the video. Please subscribe, like, and share.